Welcome to The Explainer. Today, we're focusing on a truly massive shift happening right now in the world of software development. We're talking about automating coding by taking natural language, the everyday words you and I speak, and converting it directly into fully executable code. It's an absolutely incredible process, but getting it right? Well, that requires a very specific skill.
Have you ever wondered about employing AI models for code generation? If you've ever spent hours hunting down a single missing semicolon or endlessly typing out boilerplate code, you know firsthand just how uniquely tedious manual coding can be. But AI, it changes that equation entirely. These models operate at lightning speed, fundamentally upgrading the whole software development process. But the secret isn't just turning the AI on, it's about knowing exactly how to talk to it.
Okay, let's dive into this. Here is our roadmap. First, what is prompt engineering? 2, 5 principles for success. 3, popular AI coding tools. 4, practical prompting examples. And 5, explaining generated code. Let's get right to it. Section 1. What is prompt engineering? It's a massive buzzword right now, for sure. But let's lock down exactly what it means in the context of writing code.
So prompt engineering is the deliberate process of creating specific prompts or instructions for AI language models to generate code snippets or scripts. Here's a great way to look at it. I want you to think of the AI as a newly hired, incredibly brilliant intern who literally never needs sleep or coffee. Now, this AI intern is crazy fast, capable of typing out hundreds of lines of code in seconds. But it's also highly literal-minded. If you give this intern vague instructions, you're going to get bad, unusable results. You have to define the objects, use relevant keywords, provide examples, and be totally specific. Doing this enhances the accuracy, the efficiency, and the relevance of the code the AI actually generates.
Moving right along to Section 2, 5 principles for success. How do we actually manage this literal-minded AI intern? Let's lay down the foundational rules.
There are 5 basic guidelines, or principles, that you've got to consistently use to increase your effectiveness in any code generation task. Number 1, clarify your objective and understand the task. 2, utilize keywords and specificity. 3, provide examples for context. 4, conciseness and relevance. And 5, encourage creativity and adaptability. Let's break a few of these down further to really see them in action.
Now, what's really interesting here is the clear contrast in instruction styles. You could use a terrible prompt like process data. It's just so vague. But instead, we can see the principle of utilizing keywords and specificity in action by saying something like, be explicit about the kind of data and expected actions. Including appropriate keywords communicates the specifics of the task to the model. By avoiding inconsistent, vague language, you ensure the model produces precise and focused code, rather than just taking a wild guess at what you meant by process.
Another absolutely critical principle is conciseness, meaning removing irrelevant information lowers noise and improves timely efficiency. Your prompts need to be brief. You really must concentrate only on the relevant information crucial to the assignment and cut out everything else. When you write clear and concise prompts, you're actually simplifying the AI model's decision-making process. Removing that irrelevant information lowers the noise, reduces confusion, and drastically improves timely efficiency.
Section 3. Popular AI coding tools. So where do we actually apply all these principles? Let's identify the platforms where prompt engineering is put into practice.
So the crucial point is that different tools cater to specific developer domains, but they all rely on your ability to prompt them effectively. For instance, GitHub Copilot is fantastic at taking your prompts and suggesting completions, documentation, and even suggesting new features. Then you have Google AI Codey, which specializes in web dev, NLP, and machine learning. And finally, OpenAI Codex, which assists with coding tasks in diverse domains like data science, web development, and game dev.
Section 4. Practical prompting examples. All right, let's pick up the pace. This is where the rubber meets the road. We're going to look at progressive, real-world examples of prompting, starting from the absolute basics.
Let's start with the universal starter code. This is the simplest, most basic application of our AI intern. The prompt here is exactly as it reads. Generate a Hello World program in Java. You hit enter and instantly the AI outputs the foundational Hello World code in Java. It's simple, clear, and perfectly executes that most basic level of instruction.
Stepping up a level to basic functionality, look at this prompt. Generate a function in Python that takes 2 numbers as input and returns their sum. Notice the specificity here. We name the language, we define the inputs, and we define the output. Because of this exact specificity,
the AI successfully returns a clean Python function that is explicitly named add numbers. The clarity of the objective led directly to a perfect result.
Now let's escalate things to a medium-level task. Let's break down the logical steps we want the AI to perform before we even write the prompt. Step 1, create a list of countries. Step 2, generate corresponding capitals. Step 3, combine into a dictionary mapping. This is a true multi-step instruction.
And here is the exact prompt we use to execute those steps. We tell the AI, generate Python code to create a list of countries and generate their corresponding capitals and combine them into a dictionary mapping countries to capitals. We've simply taken our logical steps from before and combined them into one continuous, crystal-clear command for the model.
And this brilliantly illustrates the power of providing context and clarity. The model perfectly followed the complex, multi-step instruction. The output shows a function defined as generate_capital, which creates a dictionary mapping countries to capitals. It generated the country names, it generated the corresponding capitals on its own, and it yielded the precise Python output to map them all together. Just incredible.
Let's look at another highly practical example. Here, we want to strictly control naming conventions and force the AI to document its own work. The prompt is, write a Python function named calculateRectangleArea that takes the two parameters as length and width and returns the area of rectangle. Include commands to explain each step. Look at that very end. By explicitly adding that, the AI not only writes the function with the exact parameters we demanded, but it actually drops in comments explaining each step. You're literally forcing the intern to show its work.
Let's wrap up our practical coding examples by fighting the complex boss of data retrieval, SQL. Here we give the instruction, generate a MySQL query to retrieve the names of all employees from the employee table. Even with this kind of raw conversational phrasing, the specificity regarding the table name and the desired data points leads the AI to successfully generate a perfect MySQL query utilizing a select statement.
Section 5. Explaining generated code. Let's move to and see how this builds, because prompt engineering isn't just about making the AI write code, it's a phenomenal tool for reverse engineering code so you can actually understand it.
Imagine you inherit a code base or find a snippet you don't fully grasp. You can present a prompt just like this. Provide a line-by-line explanation of the Python function named calculateFactorial, which takes a parameter y and returns the factorial of y. In this case, you're forcing the AI model to stop acting like a junior coder and start acting like a senior tutor. And the output here is fantastic. The AI identifies the function calculateFactorial and returns a detailed line-by-line breakdown of exactly what is happening in the logic. This perfectly demonstrates the adaptability principle we talked about earlier. You can continuously track the model's output and iteratively improve your own understanding of diverse coding scenarios just by asking the AI to explain its logic to you.
We've covered a whole lot of ground today, from the basic definitions to advanced multi-step prompting and reverse engineering. But as we wrap up this explainer, I want to leave you with this final thought-provoking question. The AI writes the code, but who writes the AI? The truth is, the human is ultimately the one engineering the logic. The AI is only as smart as the instructions you give it. So knowing what you know now about clarity, specificity, and constraints, how are you going to engineer your next prompt?